better. It's great. You got to turn on your audio or otherwise people can't hear you. Everything literally worked in testing. Everything literally worked in testing. And here we are, and it didn't work. So, gotta love when that stuff happens. Let me turn the mic gain down a little bit, because I know I'm going to blow people's eardrums out, and I apologize for that. It's been a morning. Anyways, we are going to be talking all about designing tips for success. This one has come up recently, and it's something that actually this entire week has been full of designing problems. And I want to go through why. And I think it all starts immediately with understanding what it takes to be successful in a 3D modeling position. I thought we talked about angry printers, not angry computers. You know, hilariously, here, I'll move the camera. I brought a Mini with me, like 50 miles. I set the darn thing up. I clicked print, and it worked perfectly. It worked perfectly. Like, that's an entire bed of parts for Toys for Tots. Like, could you get much tighter than that in terms of packing parts? I thought I did a pretty decent job. And it was perfect. Now, the technology is what ends up killing me. Not the one thing that you would think would be complicated and difficult. It's not the one thing that's complicated and difficult. Oh, I had to rebuild this entire thing that you're seeing. I had to rebuild it from scratch. But I had to do it by logging into my computer at home and doing it remotely. And I will tell you, I don't want to do that again. So, whatever, we might drop frames. There's nothing I can do. I have tested this. I've got a very pissed off laptop, but it should suffice. But we're going to be talking about actually, my 3D printers works better than my 2D printers. Justin Levy's correct. My 3D printers work a lot better than my 2D printer, which is hilarious, really. But it's probably because I don't use my 2D printer enough, and I've got like 6 kilograms of 3D printed parts that we need to send out to IC3D for their Toys for Tots drive. And yes, for those that haven't figured it out, I'm not at home. I'm not in my cave of making. I'm in a random room in my mother's house that I have turned into my cave of making with one 3D printer. And that means it has 100% more 3D printers than it had previously, which makes it a better room as far as I'm concerned. But we want to kind of talk about this modeling tips for success, because this week, and I talked about it a little bit, I think it was on Print Fail Friday, where at the end of every semester, without fail, like basically every semester without fail, the University of South Florida tends to bankroll the company for like 2 weeks. Every time. And, I'm getting... Please use keyframe frequency. Give me just a second. Things are mad. Of 4 seconds or less. Well, whatever. I don't understand what that means, so we're just going to keep rolling with it. YouTube is telling me something about keyframe intervals, and I'm just using auto, so it's probably fine. But we have been dealing with a class, and I don't know the class. I don't know anything about it. I don't even know the teacher because I don't want to know those things. And these are not engineering students that have been tasked with doing CAD. Now, every one of them chose Tinkercad, which is good on them. I'm very happy that they went through this process and did Tinkercad. But it hasn't gone all that smoothly for them, okay? So, and I think if we had this video literally comes because of their struggles, right? I'm doing this because of what we went through with them. Give me just a second. I'm going to post on Twitter that we're live. Sorry. I would normally have somebody else do this, but everybody's busy, so... I'm just doing it myself. Sorry for those listening audio only. It is what it is. All right. It came about this because these students clearly didn't know, like, what's going on, right? They didn't know how to design, and I'm bummed because this idea only came up after working with them, and that always bothers me when that happens. I wish that I'd kind of gotten on this a little bit earlier, but you know, whatever. It kind of is what it is. We struggled. And when I say we, I mean more the royal we. The students struggled. And I'm kind of bummed. Because I feel like as a content creator, I kind of failed. But I will say this gives me a lot of great content that we can do in the future, right? These were not engineering students that were tasked with doing an engineering job. And any of you that are in this industry, you might say, well, how hard can that be, Grant? Why don't you try doing biochem? Because I certainly couldn't do that. I couldn't do bio. I don't even honestly know what biochem is other than biochemistry. And I like chemistry, but that whole biology thing, no, not so much for yours truly. But designing is difficult if you don't know what's going on. And I'm going to talk about the two specific teams that we worked with. One of them had pretty decent CAD. They knew what they needed, but the one thing they didn't understand was the support material side of things. So let's first kind of get an understanding what 3D printing is. And for those of you that already know, hey, maybe you can correct me when I'm wrong. This would be fun. 3D printing. Well, no, Grant, don't pick up the 3D printer. There is one right next to me, so you know what? Let's just move the camera, because we can do these things. This is a portable camera. This, ladies and gentlemen of the jury, is a Prusa Mini, a 3D printer. It effectively is a computer-controlled hot glue gun that makes stuff. I know, a little bit crazy, but it makes stuff. Paging Paul. Yeah, of course, Paul's the biochem guy that we all know. Oh, yeah, by the way, how does this microphone sound? I'm trying out a different microphone. This is a Behringer Bigfoot. I don't know how it sounds compared to my normal mic. This room also has absolutely terrible acoustics, so sorry about the reverb. But a 3D printer is a big computer-controlled hot glue gun. And when you imagine working with a 3D printer, you need to imagine working with something that is making something out of wet spaghetti. If that wet spaghetti would droop, so will your 3D print, generally speaking. Yes, I know there's going to be the people out there that have their perfectly tuned Vorons or Prusas that can do beautiful bridging, but let's be real. The labs at colleges, unless it is like a college distinctly designed for additive manufacturing, are by and large not ran by students that know 100% what they're doing. And this was apparent to me when the students came and they said, we must use this material and it must be this color. I said, why? Well, that's what the school told us that we should be using. I said, they tell you what color? Well, this is all that the lab has. I'm like, oh, okay, your 3D print lab only has this color. Their 3D print lab had some problems. It's ran by student workers, and there's nothing against student workers, but you can have some issues there, where you have people that aren't trained to do the job correctly doing the job. And that can be tough, right? People that don't know what they're doing something that is mission critical for you is not okay, right? Especially when it's like, this is a final project that I can guess, because we're heading into finals and then we're moving into winter break, right? Finals will conclude, I guess, in the next couple of weeks. And so these kids are, they've worked all semester to get this project done, and the print lab fails. Hey, Jimmy, I'm glad you're here. I was late too. We've had some issues with the tech. I I definitely don't want to office space everything. And this microphone is large enough and heavy enough for me to office space everything in my arm's reach. But I am worried that that inertia on the back might be complicated. But anyways, these students were working on these designs without any input from the engineering lab. And I would love to see that change. Quite frankly, I would have loved that these teams found us earlier. Because if we could have nipped a lot of these poor design issues in the bud early, not only would they have learned a valuable lesson, they wouldn't have learned it with their wallets. These students needed parts like overnight, and I'm a business. We had to charge a rush fee. Now, before any of you go in there and start disliking the video, which you should like it, by the way, understand that we are a business. We do give student discounts. I effectively gave them no rush charge, which is how the rush charge plus the student discount kind of ended up working. But when you need parts overnight and you call me at 11 o'clock at night, which yes, I do, you can call us 24 hours a day, 7 days a week. I answer the phone. But if you call me late at night, you're going to get that rush charge. It's that pain in the ass charge. But that's all right. The thing that we learned, though, is that some of these students were not engineering majors. And therefore, they were just working together on teams, fumbling around through Tinkercad tutorials. They said that they tried to find YouTube videos. One of the teams actually found our YouTube videos, and that's how they found out that we were local. And I will say that is the most amazing string of luck that those individuals have ever come into play with. But we ran into some issues where their parts were designed to be digital. They were never designed to be printable. And when we look at what it takes to be printable, let's kind of talk about initially overhangs. That's like the big problem with FDM is overhangs, the support material, and everything that you need to make it effective. You want to avoid overhangs, and that's an angle, okay? You want to avoid overhangs greater than 45 degrees. I'm going to try to take apart... I did get it off the bed. This is a B Trixie model. I think I have no idea who made it, but this is for IC3D Toys for Tots. This part needs absolutely no support because the angles of the wings and even the angle of the stinger is less than 45 degrees. Depending on which axis you... Okay. You want to be 45 or above, okay? You don't want to be below 45. I don't know if that makes sense, but you want a tighter amount of overhang rather than a long overhang. Long overhangs will be troublesome to print. And if you have a part that has overhangs, you can design in supports if you want it, but I would question why, especially if you're new at this. With Prusa Slicer 2.4, now Beta 2, we're going to be trying that out soon. Probably won't make a video about it because I doubt it's all that different. It's a lot of bug fixes, but still good to see and have. With those support materials, especially the snug supports inside of the 2.4 beta, it makes designing so much easier. So much easier because if you have an overhang, it's no big deal. The snug supports come down. There's very little, if any, truncating of your supports into your model. And it ends up removing quite a bit easier when you can use those thin bridges rather than thick bridges. Makes life easier. Not Jeff Bridges. I made that joke and we cut it out of the video, and I'm still bummed that we cut the Jeff Bridges joke. Although that's not technically his name, but that's fine. But yes, snug supports are basically a godsend in this industry. If any of you have been using Simplify 3D and you want something that is better, faster, stronger, and cleaner and easier to do, I highly recommend you look at the snug supports in Prusa Slicer 2.4 Beta 2 at this point. But. That's not where it stops. Overhangs add time. And so if you're able to design in overhangs that are sub 1 inch long or 25.4 millimeters, do that. Always, if you need to have an overhang, make it as small as possible. Round your corners, add chamfers. Not only will that strengthen your print, but that reduces the amount of overhang that we have. Another thing to look at, if you're going to be holding your part together with mortise and tenons, or parts are going to fit together at all, zero clearance fits don't work, at least on the consumer grade side of 3D printing. If it is using filament, if it is using a raw, still in the printer, a raw plastic material like this, you need to make sure that you're adding tolerance. I don't care how good your printer is, it's not going to be perfect. And that is something to kind of worry about. We normally tell people 0.15 millimeter all the way around will give you a nice, clean, easy fit. It'll come in and out, no problems at all. 0.1 millimeter will start to be a little bit snug. 0.05, you're testing your luck, especially if you need it fast. If you do need something fast, give it a ton of tolerance. We had an individual that was doing a mortise and tenon where they had a male and female side. And I said, just give me nothing but female. And what you can do is you can go get wooden dowels from the dollar store, from a convenience store, Walmart, Michael's, Joann's, I don't care. They're easy to find. They're cheap. They're ubiquitous. Because wood is really easy to sand down. You can go on, you don't even need sandpaper. You can need concrete and you can sand the wood down. And it solves this problem of, oh, hey, on the circle that you were doing for the mortise and tenon, the hole, maybe it drooped a little bit and it's no longer a perfect circle. That's why I love utilizing wood. Carbon fiber works too, but carbon fiber is kind of nasty to support, so we are kind of nasty to sand, so we don't really do that. You will want to consider anchors, and you might say, Grant, I'm not into boating. Now, that's fine. I'm not either. I don't have that kind of money, but with your help, your subscription, your like, we can get to the SS Benchy one step closer. God, I'm not going to commit to that. It'd be hilarious, and I do live near a lot of water, but Benchies don't float. They float upside down. They capsize. Anyways, anchors. If you build in regular material up to where you need a little bit of support, you might get a better print. Hell, if you build up and basically build your own support material, that helps out. Also looking at your base contact points, right? If you're doing something that's thin and wiry, I'm going to keep using this model because I have it. If I wanted to print this and I was going to print it like this, upside down, where it's a rounded wing sticking onto the build plate, the chances of failing that are basically 100%. And I'm going to be needing to support the entire bottom of the B, or I guess this would be the top of the B, to make sure that the rest of it builds correctly. Instead, we've got a nice flat surface on the bottom. We got some cosplay armor the other day. It was a part that a client sent us from Cults 3D. It was said that it could be FDM 3D printed, and I looked at it and said, yep, it can be FDM 3D printed, but it doesn't have flat surfaces. The individual was pretty competent in Inventor. I said, okay, you can save a bunch of money by cutting it up yourself. Here's our build volume, cut it up. And that's what the guy did, and it was actually quite good because he assisted us in doing our jobs, right? When people make it easier for us to do our jobs, well, we make the price just a little bit more affordable for them, right? Less work for me, less BS for you. When we want to print something, right, that nice big chunky first layer is good, but also understanding things like if you are using mortise and tenons, you don't want the hole parallel to your X and Y axes. You want it perpendicular because then the hole will be as even as possible. But if you're using mortise and tenons, chances are you might be using a wall system and therefore need to do bridging at some point. So then you've got another problem. Well, okay, Grant, you can solve that problem by using square mortise and tenons. This is actually incredibly common in the woodworking industry because drill bits have a tendency to walk. No matter how good your drill bit is, unless you got one of the big boys and your entire system is incredibly solid and not flexible in any way, your drill bit will have a tendency to walk, therefore giving you some flexible. nature to it. Mortise and Tenon drill bits is a drill bit with then it's basically a reamer that will go in and cut a square for a mortise and tenon. Those are my favorites, a mortiser bit. Or you can drill a hole and then use a chisel if you're doing it out of wood. But this is a 3D printing channel, not a woodworking channel. When we do something like this, a flat, because I can bridge across it, and if it's small, let's say it's a 7mm piece of square stock, right? I can bridge across that all day, no problems, and you won't even notice a sag. And that means you can leave your regular tolerances of like 0.15, although for mortise and tenons, give yourself like 0.25 or even 0.3. You can fill that with glue. Every day of the week, you can fill it with glue. What you can't do is easily sand into a hole. It's a pain in the ass to get it right. And unless you have the right tools to do it, you're going to end up really hating yourself. Now, if you're using square stock, it's nice and simple to put it on a piece of sandpaper, sand it down to make it fit. But does anybody really want to go through all of that? And when we're looking at college students, look, I was in college once too. I would consider myself generally pretty resourceful, but there were times where I'm like, how in the hell am I going to do this? And remember, I have business degrees. I'm not an engineer. These were students that aren't engineers either. They're not seeking engineering degrees, and they ended up needing engineering. I've always wanted to do like this intro to Tinkercad, but I don't know the right way to do it I don't want to sound like I'm pandering or like talking down. So if you guys have ideas for like videos on Tinkercad and how we can kind of build this, because I love the Back to Basics series and we are going to continue it, but it's got to be done with programs that we can really sit down. And I've always thought about the idea of doing like, little like YouTube shorts, like little 1 minute, how do I do this? How do I do that? Bing, bing, boom, we're done. That would be awesome. Because then when you're looking for these particular problems, you can find the solution quickly, right? Understanding how those keywords work. I'm going to be reaching out to those teams saying, what did you guys try before basically saying, screw this, we're going to pay a professional. But I think they got lucky in that they chose Tinkercad. Tinkercad is basically Minecraft, but CAD. It's really, really easy to build in. They're building blocks. They can easily fit together, but understanding how strength works for 3D printing is another issue. I actually talked about it in Print Fail Friday where I showed off one of the failures. The brown parts in this previous Print Fail Friday, it came out yesterday. If any of the staff are listening, throw the link in the chat for me. That print was actually one of the school project prints. And I was a ding-dong. I should have actually printed it on 2 different printers, and I didn't because they really wanted one color and only had one spool. They actually asked for the Jesse PLA Mix Record number 7. I believe that Tinkercad is perfect for kids. I believe it's a little bit tough as you get older because your expectations are different, right? When you're, like Jimmy says, 12 to 15 years old, it's totally acceptable. But when you're in your 20s, you might want more value out of it. Now, I will say, when we looked at Tinkercad for the first time a while ago, like looked at it again, because I'm basically using Fusion for everything, it was way better than it used to be. So I will give Autodesk credit. They are not just like turning it into a pile of garbage. So good on you, AutoCAD. Thanks. Or Autodesk. Thanks for not being jerks 100%. But Tinkercad's not really designed for 3D printing. I would love if, and I think we talked about this as well, I would love if we could have programs where you're designing and you're saying, I'm going to design for FDM 3D printing, or I'm going to design for resin 3D printing, or I'm going to design for SLS, SLM, DMLS, CJP, whatever you want to use. And it modifies how it yells at you. And if it yells at you when you're doing things wrong. And it can help you understand this better. I believe that is kind of one of those problems to where we could look at getting 3D printing into the home. My dad and my mom have taken a lot of like interest in the technology since the channel, because like they support what I do. So thanks. Quite frankly, they're probably watching it in the other room right now, which is kind of weird. I can't hear myself echoing from their TV, but I can hear myself echoing in this room. But the technology, when you boil it down, is not all that complicated, right? Printing stuff is quite simple. I say that because Prusa Slicer is a thing. But 3D printing itself is pretty simple. The design work is where everything fell through. And one of the teams, boy, did they struggle. And I feel for them. This was your typical college project, your typical project. I'm sure a lot of you that are hanging out with us right now might know what I'm talking about, where one person is left to do all the work, and that person is you. This is a holiday weekend here in the United States. That's why I'm not at my desk. I'm down with family. It is Thanksgiving weekend. Thanksgiving was Thursday. Then we had the worst shopping day of the year, where you should never go out into public, Black Friday. And then, of course, we have my favorite shopping day of the year, Cyber Monday, coming up, where I can stay inside and buy things that I probably don't need. But I will say Printed Solid's got some great deals on filament, and I might have spent over $200 on filament. So if you like really cool colors, and a lot of it being Polyalchemy Elixir, make sure you get subscribed for that. Once I fix that time-lapse printer. That's a whole different story. But I would love to see where, like, I feel like my dad could do design work if we solve this problem of what is printable and what isn't, and teaching people that from the beginning. And Jimmy's right. Jimmy says the most important thing to start thinking in to start thinking in 3D while designing. For the technically inclined person, Fusion 360 might work to start, but Tinkercad can be better for people with interest. And I agree, because in Fusion 360, you design a 2D something or other, and then you extrude it. And whether you're extruding it to create an object, delete an object, cut a hole, whatever, that doesn't always make sense. And it took a long time for me to wrap my head around it, and I still suffer from it. I'm going to give a big shout out to Mad Monkey for not being there when we needed him, but then being there to solve the problem the next day. It was funny. He was spending time with family, and myself and 3 other people struggled with a very stupid problem about lofting. I was trying to hollow out a fan duct, and I was trying to loft a loft. Okay, that's a loft inside of a loft, and a loft connects to surfaces. Okay, so let's assume they're 2 surfaces, and they get connected, and you can connect them over a path, if you will. I didn't know that if you just went with the shell command and clicked the 2 faces you wanted open, it's done. You're done. And it's really, really simple. Oh, that would have saved me like 3 hours of frustration, because I get very frustrated because I realized that, and it was the exact issue that I had today, not only do I not know how to do something, I don't know how to ask how to do it. Great example. I was trying to export my scene collection for not for Fusion 360, for OBS. You might notice that the background is a little bit different than it normally is. That's because I don't have the right scene. When I went to OBS, I tried all of this at home the day before, and it didn't work. Or it did work at home, but it didn't work when I got here. Why? I ain't got a snowball's clue. Makes no sense to me. But I'm here like 25 minutes before I need to go live, freaking out because I don't have anything I need to go live, and we have a set way of doing things, and it is inflexible. I do things the way I'm very, very schedule-based. For those that know me, know that it is both a blessing and a curse. I am generally never late to things, but when time is up, and I have to get things done. I ended up actually building this from scratch. What you see, I built completely from scratch. Sorry. It wasn't a lot of fun, but I did what I had to do. But that was difficult because I had to build it on my computer back home because I don't have the software that I need on this computer. But the big takeaway, and it's the constant takeaway that I get, is not only do I not know how to do something, I don't know how to ask how to do what I want to do. I was trying to export a scene, the scenes inside of OBS, but keep the backgrounds, the text tickers, all the things that I needed to have. I didn't know how to do that. And I didn't know how to ask Google to do it for me, right? I even went to Reddit. I put a post on Reddit. Didn't get any responses in the right amount of time. So it tells me, all right, we have a need. But I still have to solve my own problem. So these students are likely going through the same thing. they're trying to build something, but they don't necessarily know how to do it. They had a size constraint. In this particular team where the one person was left to do all the work, the size constraint was 6 inches by 6 inches by 6 inches, or 152.4 millimeters, I think, XYZ. It's like 100. I made it 150 with them. I said, all right, here's what you're going to do. You're going to build a box that is 150 millimeters X, Y, and Z. Your vehicle must fit inside of that. The work that they were given from their teammates was 6 separate pieces, every single piece, which they fit together to make one long car. Each piece was over 115 millimeters each. Now, I'm not the best mathematician in the world. I certainly make dumb mistakes pretty often. But what I can tell you is 115 plus 115 plus 115 plus 115 is greater than 152.4. And that was a problem. Even further, she just sent me all the parts and said, hey, can I get a quote? I'm like, yeah, I can get you a quote. It was 4.5 days of printing on a single printer. I said, look, I mean, you're talking like $500+ to get it done overnight. I'm going to have to shut down all my production, run you on, I think we were going to have to run like 8 or 9 machines to get it done overnight. But we were willing to do it, right? You know, when it's a school project, you do what you got to do. And I said, send me the files. Let me take a look at everything. And I said, do you have any specifications that you need? She said, yes. I said, send those over too. I'd like to make sure that you're staying within spec. Her team abandoned her, so I wanted to make sure that everything was in spec. It wasn't. And so I spent the next 3 hours of my day, my night actually, we were on from like 9 to midnight because it was a Tuesday and I was busy, going through how to build this. Like I sat there and designed it with her, right? I talked her through how to build it inside of Tinkercad, what she needed to do, how to take measurements, and I helped out. I showed her GrabCAD, which I will say is the cheat code for a lot of designing. If you are looking to make something and it has interior components in it, like screws, hardware, anything, go to GrabCAD. If it's hardware related, go to McMaster-Carr, because McMaster-Carr basically has step files for everything that they sell. It's really convenient if you're trying to put it into something that you need. But she was not technically inept enough to do the design work, so I did have to step in a couple of times and help out. Great thing about Tinkercad is that it is cloud-based, so I was able to help her out. The big thing was she didn't understand the technology. She had really never seen a 3D printer before, so the technology and how it functioned was not immediately understood. And that's a pain in the ass. I've been there before, right? When we first started 3D Musketeers, I didn't have a design ability. I downloaded stuff from Thingiverse. I paid other people. And now I was the person that was being paid. So I've learned over the years. I'm not great, but I'm good enough. And we spent 3 hours designing it. And at the end of it, she legitimately came out and said, I'm going to get Fusion 360. I'm going to learn this because I like it. She said, I'm not under any circumstances going to change my major. She's pretty deep into her major at this point. But I think it is really cool. And, you know, I called that a win, right? I called that a win for the technology because, you know, when you get those phone calls from people and you can tell they've just been through some shit that day, right? You know, and it's a phone call, right? So you can't see it in their face, but you can feel it. It was one of those where it's like, you know, I don't know what you're going through. Quite frankly, it's none of my damn business, but I want to help you. And then she said, well, what about the wiring? I said, well, what is it? It was a 2-wheel drive Arduino car. I said, you do know that like all of this is open source and online, right? She's like, no. I said, yeah, Google this. And she found all the code. So she learned to program Arduino. And you could see all of a sudden these hamsters that were just waiting to jump off a bridge got back on the damn wheel and they just did a line and they were going at 1,000,000 miles an hour as her brain and problem solving skills kicked in. And I will say that was really, like, it felt cool because I know how this works with me. And of course it doesn't always work great for others. I guess my dad is watching because he's commenting. At what point does the level of detail of the design complicate the actual 3D print, or should the designer limit the amount of design detail? That depends. And unfortunately, a lot of the answers to these questions are it freaking depends. Design detail can be great, but it can also be your Achilles heel, which I don't mean to make in jest, because my dad did have like an Achilles tendon injury many, many years ago, but that is kind of funny. You can make a beautifully high poly model, but the 3D printer is not going to capture it. We tell people if your file is over 25 megabytes, it's too large. You don't need that kind of detail. If you're going to resin, 65 megabytes is my limit. If it's above 65 megabytes, decimate it. Decimation is where you simplify the model by reducing the triangle count. I will say there is a, what's the word I'm looking for, where it plateaus, right? Where, the term, and you guys are like 20 seconds behind me, so I don't know for sure. There's a term I'm looking for where things plateau. Diminishing return. There it is. Diminishing return. There's a diminishing return with designing, and especially if you have to do this when it's mission critical, just keep it freaking simple, right? I don't want to see a crazy complicated model. I mean, I do, but if you don't have the skill set, don't put yourself under that pressure. Like Brian Weber says, try not to turn a simple design into a Swiss watch level. As someone that does like Swiss watches and doesn't own any of them, which is fine, I don't have the budget for them, but I love how they work, don't do that, right? Unless if you have the skill, do it. We got a, what was it, tri-axis tourbillon from the My Mini Factory thing. I've always wanted to print that, and I haven't had the chance. Maybe that'll be the next big print that we do. But yes, keep your design simple. These vehicles had to have some sort of look to them, because otherwise I would have just made a damn box and I would have glued stuff to it. Feature creep, my brother is talking about. Tarzman's my brother, and he's talking about feature creep. Feature creep is a big deal too. But let's back it up to design complexity real quick. You do want to make certain, very certain, that you cover your bases for what's needed. For her, 150 by 150 by 150. I don't give a damn what the rest of it looks like. If it doesn't fit in that 6 by 6 by 6 inch build volume, it doesn't matter, which is actually kind of cool because a Prusa Mini is 7 by 7 by 7. So if they made a car in one piece, the Mini could have printed it, which is pretty cool. And I said, that is the most important thing for you to do. Everything else, hot glue, duct tape, not baling wire because that will cause shorts, and some super glue will solve every problem that you have. Right? Now, she had very little experience with soldering. Actually ended up, since they couldn't find a soldering iron, they came out to the set and they soldered on set. I taught her dad how to solder, her how to solder. The mom had no desire to learn how to solder, but we were here and they needed this done so it could work, so we did it. And I let her do all the work, which was really, really, I don't know if validating is the right word, but it felt good to see like something that you're teaching somebody that you were taught by Mr. John Winchester. Going to give him constant shout outs for all the stuff that he taught me when I was younger. Maybe my dad taught me to solder, but John Winchester taught me how to solder good. NASA aeronautical engineer is going to know how to solder better than my dad. No offense to my dad, but John Winchester was better at soldering. But, you know, that man designed the decoupling system for the Saturn V rocket. So he's been around the block when it comes to electronics. But either way, making sure that you understand where things can go. I said, all right, you want to keep this as thin as possible, but you need to make sure that everything is still stiff. I said, I can make stuff stiff. She said, well, isn't it always solid? No, 3D printing is not solid, and you need to take that into your design as well. These are not the greatest. Let me see if I've got a model where we can see inside of it. Maybe. Let's see if I can get OBS to show it. Oh, yeah, you guys can kind of see it. Focus. Thank you. You can see the X pattern in this penguin here. The X pattern is the infill. This penguin is not solid. And it shouldn't be. There's no reason for it to be. It's a waste of time, it's a waste of money, it's a waste of resources, and a waste of everything that actually matters. Because why not? Also, I am sitting at a desk that was owned by my grandmother. I don't know how old it is, but it is pretty cool. It's an old desk. And I think it's gilded. It's got gold leaf in it, I think. Anyways, I tangent a lot when I'm alone. This is how it works. But understanding that you're going to have interior volume, there's no reason, if you don't need it, to make it look pretty. I worked with her and I said, all right, what is your key goal here? Well, I need to make it look like this. I said, nope. What's your key goal here? Well, it needs to do this. I said, nope. I said, your key goal is that it works. Because if it doesn't work, nothing else matters. Cue the Metallica. This isn't an edited video, but that's how that would normally go. I'd be like, Metallica. And then I would keep going. Then Andrew, our editor, would come in and say, nothing else matters. And then hopefully we don't get a copyright strike for that. And demonetized. That's how things go pretty quickly. Designing, though, you have to really look at it as if it's being built layer by layer. And if you wouldn't build this out of paper, building it out of plastic is going to be just as difficult, if not more difficult. And once we kind of explain that whole wet spaghetti building out of, hot glue guns and etch-a-sketches, it made sense. And it took them a bit, but we figured it out. Hilariously, I was the one that ended up failing. They had the cover for it was really thin. It was 1.5 millimeters thick, and it was tall. It was 150 millimeters because we made the thing as big as possible. And I didn't put a brim on it because if you like it, then you should put a brim on it. And my dumbass forgot that, and it broke off the build plate, creating a nice warm plate of mom's spaghetti, which would have been caught in the time lapse, but the time lapse failed. It's a thing. It's a thing. You want to look at what is your critical axis, and what is your critical axis for not only dimensional accuracy, but also strength. Your prints are weakest in the Z-axis, and they are most accurate on the XY, generally. If your printer is tuned well, it will be most accurate XY. The reason is, if you're even a little bit over extruding, that top of your part in the Z-axis might not be in spec. A little bit of sandpaper and it deals with it. And if you have multiple axes that need to be critical being, these must be perfect, it is inflexible. If these are not perfect, we have problems, split the model. I guess this project required 3D printing. Because I looked at a lot of these projects and said, I could cut this on the laser like 10 minutes. And it would cost you 1/10 of what you're being charged. But they all were very strict in that it needed to be this way. So I don't know if that's the way it works, I guess. It may not be, it might be, who knows. I believe that if you're going to cut things up, having indexing, and whether that is a cutaway where it only fits in one direction, a pin and hole system, Mortise and Tenon, or you're just good, right? And my heart broke. The first team that came out, I gave the guy the parts. 7 o'clock in the morning, by the way, I met the guy with the parts, and he instantly dropped it, and it broke. It landed on a very thin area and the part broke. Thankfully, I had my methylene chloride, otherwise known as 3D gloop, handy, and we were able to bond that back up for him. But you could tell they were pretty close to just throwing in the towel and saying F it. And I don't like that. And that's not fair to them. But if they understood that design process, they did cut their model in half, but they cut it in such a way that it wasn't going to be strong. And had I known what they were making, what they needed, I could have made that area stronger for them. And I think it's important when you do work with someone or you work with anybody in that way, make sure that you tell them, this is critical, this matters, I need this to be this size, because remember, when you work with professional companies like 3D Musketeers, we're not just going to say, hey, thanks for your print. Here's what it costs. Go screw yourself. Give us some money and, here are your parts. See you later. I have conversations. And I don't know the YouTube name of the person that called me earlier in the week. We had our first fan call in, which was kind of cool. I don't know if anybody knows this, but the shop phone rings directly to my cell phone. So if you have a question and you want to ask, just call me. It's like what I'm here for. Now, I might be in meetings at the time and I'll get back to you, but you can call it. You can even text the shop number and say, hey, I'm a fan of the YouTube channel. I got a question. Can you help me out? And I'll say, yeah, you free in 20 minutes? Or yeah, give me a call and we can talk about it. Because I love helping people. It also gives us cool ideas for future videos, which is always good when you're a content creator. But there's more to look at, right? Why did my part fail? My part failed because I instructed her to make it fast. And fast meant sharp corners, thin parts. And me it was like 2 o'clock in the morning when I was finally able to print it. I was tired. I wasn't really paying a ton of attention. And I didn't put a brim on it. And you could also look at doing something called mouse ears. Yes, that mouse. the Mickey kind. That if you even show their logo, they tend to send the lawyers coming at you. But that's okay. It's just the way things go sometimes. If designing in the mouse ears mean at corners, you have an extra little piece. It should be 0.2 millimeters or 0.4 at the thickest, because then it can just be cut off quickly with an X-Acto knife, a flush cutter of some sort, whatever it might be. That's all possible. You then have to look at, okay, I've got the corners handled. What about the rest of the part? Thin parts over time will have a massive tendency to warp. What I ended up actually doing to solve a problem is instead of printing it vertical, I printed it horizontal. Meant I needed to add a little bit of support material, but it got it done in lickety-split rapid time. And that is absolutely, kind of my goal. We also need to look at how the part will go onto the build plate. If you're printing the model and it's got nothing but round surfaces, you've got a problem. If you're trying to print a sphere on an FDM 3D printer, chances are it's not going to print great because of the support material and the way that the material has to build up. You have to cut it into slices, right? It's like an onion. Try building an onion out of slices. You're going to have a hard time doing it. Although that sounds like a fun challenge. But the reason it's going to be difficult is that you don't have something flat to stick on the build plate. For a sphere, cut it right in half, bisect it, print it, glue it together. Bob's your auntie, you're done. Actually, Bob's a good friend of mine, and Bob always wins. Hashtag Bob wins. But I think a lot of these are useful if you know how to design already. They're not useful if you don't understand it. Try to make the thing that you're thinking of in your head. But I want you to make it in layers, the thickness of your hair, really thin. And you might struggle with that. And that's because it's not designed properly. Nice, flat things. Jimmy says, I can build an onion out of layers. Jimmy happens to be one of our patrons. If you want to support us directly, you can do so at patreon.com/3dmusketeers. Jimmy, you're in the Discord. I challenge you to a duel. Go ahead. I want to see you build an onion out of layers. No, you're going to 3D print an onion. I want to see you cut an onion up into layers. Thin layers, all right? I'm not talking these 6 millimeter layers. I want to see it cut up into thin layers and rebuild it so it doesn't topple over. Chances are it's not going to. But I'll happily be proven wrong. And if I am, I'll tweet it later on in the week because it might take Jimmy a little bit to get it to me. But Jimmy's in the Discord. So he'll send it to me and he can ping me directly. This comes down to understanding, oh, here we go. This will work. Will this work? This totally works. Find random things in the house. This is some sort of weird ceramic egg. On the bottom, it's got a flat surface where you can easily put it onto a build plate to print it. Something like this won't work otherwise. I don't know what it's decor, apparently. I don't know. I don't do the decor thing. Like, this is the most art you've ever seen behind me. It's weird. But understanding that flat surfaces create buildable surfaces is what you need. You can print something that is round from a build plate. It might not look great. But yes, just horizontal slices. Just horizontal slices. The more surface area you have on a print, the better. Caveat, as long as it's a regular material. PLA, PETG, more surface area, more better. Most of the time. For materials like ABS, polycarbonate, nylon, those materials suck to 3D print with anyways, so be careful. They have a tendency to warp. Even PETG and PLA can warp over time. As they cool, they'll shrink a little bit, and that will cause it to curl and warp. So while you do want surface area, you want to avoid those sharp corners, which create stress risers. A round corner will be stronger than a sharp one. And that even moves forward into manufacturing. There's no such thing as sharp corners in injection molding. They're almost always rounded, even just a little bit. Just horizontal slices in regards to an onion. That's right. We're going to be cutting onions today, boys. It's going to be a lot of fun. And I would love, and I'm going to challenge Autodesk. I'm going to reach out to them. I'm going to probably tweet at them and say, hey, Autodesk, I want to teach more people about 3D printing, but the problem is we don't have a good way to design. Fusion 360 is okay. I would say use FreeCAD, but I had a really tough time using FreeCAD. There are people that enjoy it. Its UI I could not get behind, but it's because I've always used Fusion 360, Onshape previously, and then Solidworks previous to that. I could not get my way around FreeCAD. I'm going to keep trying because it is open source, legally free, and all the fun jazz. But Fusion is kind of what we use and why we use it. It is important to understand that if you don't know, contact a professional. Hi, I'm a professional. This is literally what I do. I am sitting in what could quite literally be one of the most uncomfortable chairs I've ever sat in my life. This chair is probably older than me. I'm actually fairly certain it is older than me. It's in better shape than I'm in. It's only got a couple of scrapes. I've got a screwed up back. And this chair back, while uncomfortable, is still in good shape. Making back jokes. That's how we get by with our day sometimes. I do this because I want people that don't know to reach out. A phone call doesn't cost a dime. An email doesn't cost a dime. A text message doesn't cost a dime. But if it reduces your stress, you can succeed. I'm here to help you, right? I am a professional in this industry. I am not just here to take money. It'd be great. Patreon and such. But you know, we do a lot of things because we know it's the right thing to do. Whether it's the easy thing or not is completely irrelevant because the easy thing is not always the right thing. And generally speaking, it's not the right thing. But when you are doing your design work, you have to think like an engineer. And if you're not an engineer, call one. Whether that's somebody at your school, you can reach out to them. Whether it's somebody in the company, you can reach out to them. Whether you're saying, you know what, I'm afraid of reaching out to people that I know, call us. There's no such thing as a stupid question unless you're trolling, and then I'll call you out. But that's fine. Understanding that if you don't have, I'm going to pick this up. If you don't have good build plate adhesion, things will fall off. These are the two models that I took off earlier. Put them back in their spots. If you don't have good build plate adhesion, things will fall off. But as you can see, it's like a Dairy Queen Blizzard. Things don't fall off until the build plate gets warped. Am I going to do this on camera? Yeah, what the hell. Until the build plate gets warped. And then you can see one fell on the ground. That parts come off. Now the dolphins are multi-part pieces, so there you go. They're wiggly. But build plates can warp too. So keeping an eye on material usage, where it's being used, why it's being used, and all of that will help you design for success. I'd love to know what you guys think. I know we got a couple of people here hanging out. Oh, those scrapes, it's called distressed in the chair. The chair, the chair is older than you too. Wow, that's in better shape than you are, Dad. Anyways, I didn't know if I would be out of town for this. If I was in town, I would have shown you guys some fusion work and shown you some models that were designed well and ones that weren't. So I apologize for not having all of that here. I don't have fusion on this computer. But I still do believe that it is valuable. It's valuable because designing properly, designing efficiently, makes it so that you spend less money. If you've made the decision to already work with an engineer, a professional, a 3D Musketeers, you've already committed to the fact that you're going to spend money. The family that I worked with, the mom said, this is our daughter's education. It's the most important thing right now in our lives. We don't care what it costs. We just need her to pass this class. And I feel that. And I think any parent out there will understand that feeling and what it's like to say, I don't really care what it takes. If it's $1,000, it's $1,000. It's cheaper than taking the class again. Although I don't know if that is. It could be. But I looked at him and said, I'm going to do my best to help you. You don't need to pay a ton of money. What you need to do is know how to design. And, there are some times where, while this year has not been financially amazing for us, that as the owner, I get to do the things that are tough, where I get to say, I really should charge you like $900 to $1,000 for what I did. I spent like 6.5 hours with them over the course of 2 days, plus the printing and all of that. I should charge them, $150 an hour for my time. But like police, I have discretion. And I said, you're not doing this because you waited until the last minute. This student, like, if you clearly waited to the last minute and you needed to be bailed out, I'm not going to feel for you because that's your own damn fault. But in this particular case, it wasn't their fault. They didn't know. They didn't know that what they were going to get was going to be garbage. They didn't know what they were going to get wasn't going to work. And so I'm able to apply a little bit of discretion where I can, and I could certainly use the money. But it felt better that we were able to teach somebody something they wouldn't have learned otherwise. And they left with an education. Maybe not an amazing one, because, I was working for 6.5 hours on a project with them. So at a certain point, I'm in just a lot of pain, and there's not much I can do about it. Standing for 3 hours, let me tell you, incredibly painful. But when they left with the way to do it properly, I felt rewarded. Don't get me wrong, a bank account that's heavier is rewarding as well. But that doesn't solve their problem. Duff says it's difficult to get people to accept a reasonable price these days. It is, especially when they're in college, right? If they've never had a job before and they've always lived at home and all of that, understanding what things cost may not be 100% there for you. But I also recognize that it's not fair to charge them that amount when it's not their fault. If this was a singular project and they put themselves in this bad position, screw them. They got to pay. But if they legitimately got screwed, there's no reason to hit them again, right? Don't kick somebody when they're down. It made more sense to teach. And it inspired this episode because I want to be that place where people come to learn. But I'm not exactly certain how I can do it. Like, I know in my head what I want to do, but I have to get a way that I know what I'm doing. And I don't know. I think we need this, and I think I'm going to start a completely separate YouTube channel just for this, because I don't think it's going to work well on this channel, because the people that watch this channel already own 3D printers. So you guys, I don't know, maybe we'll just do a YouTube Shorts thing all about it. I don't know yet. But I feel like if you understood the basic concepts of like, hey, let's reduce chances of warping, right? These build plates are spring steel, they can warp. Let's reduce abilities to warp. If it's thin, put a brim on it. Let's look at everything that we can do to be successful. Because if you don't, you're going to end up paying dearly. I don't necessarily have the right answer. And I think that's the hardest thing for me, is that I don't have the right answer. Because every single process, like resin 3D printing, is a completely separate process. And I want to just kind of stick more to FDM today. But I'm not certain how to communicate this to people that don't know, other than call me. You have to look at your project and look at it and say, all right, I'm going to be building it out of sequential layers, layer by layer by layer. How do I do this in a way that makes it effective, efficient, and easy? Because once I explained how this technology worked, and I said, hey, go watch one of our time lapses, see how it builds up over time, that is where it clicked. But if you don't know where to look for that, you may not even know how to find this video. And that's kind of the struggle. And like a 3D design for dummies is just, it's not nice. I don't know, guys. Let me know. If you want to do it on the main channel, let me know a name for the series. And let's get some comments. Let's figure out what we want to do it on. But I do believe it's necessary. I'm tired of seeing people suffer, right? And this is not physical. It's all mental. But when you're a student, your mental health is an incredible, I mean, when you're anybody, mental health is incredibly important. But when you're a student, staying sane out there in the midst of all the bullshit going on in the world and trying to go to school in the middle of God knows what's coming next, and it's not easy. And if you are met with a challenge like this that is just as difficult as what you're used to, how does it solve any problems for you? Spoiler alert, it doesn't. For FDM, you want to reduce overhangs. You want to make sure that your parts fit cleanly onto a build plate. If you know you're going to be 3D printing, talk to the people that are going to be printing for you. Whether you're doing it yourself or somebody else is doing it for you, talk to them. They will give you specifications that you need to follow. Understand that you can't have zero tolerance fits. You must add tolerance. And if you're doing it in Tinkercad, make sure that you understand the way to do it. It might not be easy, but you can do it. I want to help everybody, and I know that I can't, right? I believe I would be a great medical professional if I just didn't randomly get squeamish and pass out. That's a problem. So instead, I want to help people make cool stuff, and I'm dating a medical professional. So, you know, all the cool stories, but none of the hard work. But it is quite simple once you understand it. Understanding that you need to take the model and cut it so it's flat. Understanding that if it's a hole and it's parallel with your X and Y axis, it might not be a hole anymore. Understanding that printers might not even print crazy accurate parts. That's all important. Things like Mortise and Tenons never print the male side. Always do 2 female sides and then use a pin. Get a separate pin, whether you print the pin, you make it for the size of like 3mm filament or 2.85mm filament or even 1.75mm filament, or you end up using a steel rod, a plastic rod, a wood dowel, something like that. I always say to use square pins and pegs when you can. It's easier to 3D print, and you can then even print the peg because it's just a little bit of support material. All of that can result in better prints. But really understanding how the technology can assist you, I think, is where it comes down to. Designing does not have to be difficult. What is difficult is the understanding. Think of it like you're cutting something into very, very thin slices, right? Like when you go to the grocery store and you say, I want the deli meat sliced thin, and they just shave it, right? And it's basically falling apart when they show it to you. That's as thin of layers or thinner that you're getting in a 3D printer. So try to build something out of deli meat. Don't do that, Jimmy. I want to see you rebuild an onion horizontally cut. That'd be so cool. Although I guess you could cut the onion any way that you wanted. You just have to build it with horizontal cuts. I want you guys to help out. Those of you that know what you're doing, leave some comments. Your best pointers that you can. Leave some comments. I'm going to, because we do release these audio only, I'm going to put the link to the video in the audio only. And I hope that the people that are listening to the audio only find the video. Because if you need it, you need it. I want us to build a library of whether it's, images like graphic design images that show things like, this is how to do this, this is how to do that, or we do small videos. I believe that is really the key to design, is having the proper library available to learn from. Because as far as I can tell, there isn't one. And that's a little upsetting to me. So I want your guys' help. Let me know what I can do. I'm here to help. My entire team is here to help. That's what we do. This was going to be a short episode from the beginning. It was never planned to be something that was all that long. So I do appreciate you guys hanging out with us. You know what? Let's hit SLA real quick. SLA is pretty simple. SLA, resin 3D printing. If it's a thick part, it's going to end up getting hollowed. Make sure that you have room for holes. If you are doing a mortise and tenon, great. You just found your holes. You can design out the female portion, then just cut out the end of it, and that's your drain hole. Support material for a resin 3D print is totally different. Instead of printing flat on a build plate, resin is pulled up and out. So a lot of times the part would be at an angle to reduce the cross-sectional area that touches the FEP sheet. Give you an idea, resin 3D printing is a vat with a piece of plastic called FEP. In that lies photosensitive resin. Don't breathe it, don't drink it. It's a forbidden milkshake. Resin is toxic. And don't aerosolize it, for God's sakes. I'm still pissed off about that video. Like, many days after I filmed the Print Fail Friday, that video still upsets me because I know people are going to watch that guy's video and they're going to do it and they're going to end up in a freaking hospital. And that really upsets me. Anyways. Resin, you want to reduce your cross-sectional area. But if you hollow a model without drain holes, you create suction cups. Suction cups cause your part to get ripped off the build plate. It's stuck on there with chemistry of some sort. It's the grain in the build plate, plus it sticks to it. It's magic. Assume it's magic. But when you deal with resin that gets trapped, it will find its way out, and it will do it violently by popping your model. You don't want that. But what you do want is to make certain in FDM, more surface area, generally more better. That doesn't mean to cut your model up so it has tons of surface area. It just means make sure you have a printable area, a printable surface that has a fair bit of surface area, right? I don't need the biggest flat side to be touching. You have to look at what has the least amount of overhangs, the least amount of support. That's what we would look for in FDM. In resin, we look for how can we reduce that cross-sectional area. So they're a little bit different in their thought processes. When you're designing for resin, generally speaking, a lot of the rules in FDM are thrown out the window. With resin, you don't want things that are randomly hanging out there in the cabbage. They're going to be tough to support, but that is identical for what it would be in FDM. The difference is in FDM, you can play with tolerances. You too can do this in resin, but you must print the parts, flat on the build plate. You can't support it. It must be a part that prints with 0 supports. If it has support, it's probably not going to work. Resin needs more supports. It does not bridge well at all, if at all. Whereas FDM can actually, some machines can bridge quite well. And a lot of that comes down to who's running the printer. If you're concerned, reach out. If you need help, reach out. We are here, 3D Musketeers. This is what we do. This is why I do it. I do it to help people like you. But yeah, I think that's all I got. We started really late. I apologize for that. It's not the way I like to do things, but this laptop was basically destroying 65 to 70% of the frames. I still don't know what fixed it, but it's fixed. Yeah. But at least, because I've streamed from this laptop before when my desktop used to crash all the time. We would stream from the laptop. So I know it's possible. I just don't know what happened to all the files that I had. Anyways, guys, I appreciate your time. I hope you all are, if you're in the US, I hope you're enjoying some time with your family, of course, as safely as possible, because you do need to stay safe out there. You need to call your loved ones because you probably haven't friggin' done it. You need to keep making awesome. I'll see you guys in the next one. Take care. Leave some comments or something. I really want to see some comments because I really want to make content around this because I think there's a lot of good content to be made. Hope this helped. And if it didn't, all the information you need to reach out to us is in the description. So just do it. Just reach out. It's a tough one to do without physically showing you guys. And I'm not able to do that. It's difficult. We might do a designing live stream where we do like a designing for beginners. I don't know. Let me know your thoughts. I'll see you guys later. Take care.